X Windows, the underlying graphical technology of the GUI on virtually all versions of Unix and Unix-like operating systems from the mid-80s through to roundabout now. But given that the use of Wayland is on the rise in many a Linux distribution, we are perhaps beginning to see the swan song for X, so figured it was time to talk about it. I mean, it's old now. Now I should warn you before we get into this video is going to be long and it's going to be nerdy. Many of you have told me that nerdy is right up your alley and that's why you subscribed in the first place, so you're really hoping that's true. As depending on how you cut it, we've got nearly 40 years of history of X to go through. And let's start with the elephant in the room, the thing some of you have been itching to put in the comment section already, and we're only like about 20 seconds into this video. And despite the fact that most people who have ever used X Windows calls X Windows X Windows, and that virtually all the tech press calls it X Windows, it's not actually called X Windows. Formerly, it's always just been called X or X10, X11, etc. depending on the version, or sometimes even, at a push, the X windowing system. But officially, it's never actually been called X Windows, despite the fact that a lot of people call it X Windows, and throughout this video, I'm probably going to say X Windows quite a lot because, you know, me and everyone else called it X Windows. So with that pachyderm safely ushered out of the room, let's get on with the rest of the video. Despite X's common association with Unix and being the main graphical subsystem for Unix, it didn't start on Unix. To go back to the beginning of this, we have to talk about an operating system called V. V is an operating system that was being developed at Stanford that probably no one has heard of. In fact, probably the best known thing about it is it's where X started. Again, sort of, we'll come back to this. Anyway, V was a bit different to other operating systems in that it didn't run on one single computer. By that I mean it didn't just target one platform, I mean it ran on multiple computers at the same time, and the entire point of the operating system was that all the different bits of the modular kernel would be running on these different machines and talking to each other over Ethernet. So everything in V involved message passing. If you want to get anything done, you did it by passing messages to various bits of the operating system that may be on the same host that your code's running on, or an entirely different computer, and it goes over Ethernet. Now, the reason I mention all this message passing stuff is it's pretty important to why X is the way that it is. Because in a system like this, the frame buffer that's linked to your screen is in one computer, the code that's trying to get it to display something running somewhere entirely different potentially. So when they designed the W windowing system for V, or just W for short, it had to fit into this message passing system, with the idea that the application could be running in an entirely different computer, so it had to manage its display by having messages passed to it about what it wanted to be displayed on screen at that point in time. And it would have to message back those applications with what's going on with the keyboard and mouse. And this idea is the core of the whole X display system. So it's important that you get to hear why it came about in the first place. Now in 1983, Paul Asante and Chris Kent decides to port this thing to Unix, so they can use it with a newly acquired workstation 100 graphical terminal. Now a copy of this code is given to MIT's computer laboratory, where in 1984, Bob Schiffler decides to replace the synchronous protocol in W with an asynchronous one. He also decides that as it's not compatible with W, he's going to rename it, so he increments it by one letter and we go from W to X. And this is where we get the first ever version of X. And also, X sounds cooler, right? We all know that. See, Space Karen, you didn't even invent the concept of randomly renaming things to X. Now, before we go into how we get from this version of X that Bob Schiffler knocked up in about a fortnight to, you know, the X we all know and love today, it's worth looking at why X developed the way that it did. Because it's a product of a computer environment from the time it was created in, rather than one from the time we're in now. See, back in the late 70s and early 80s, Unix systems were typically a big mini-computer. I know that seems like a bit of an oxymoron, but you should see the size of some of these VAX systems, where users didn't connect to it directly. VAX users weren't all sat around their VAX computer working. For a start, these things are big, they're noisy, they drink a lot of power, they output a lot of heat. You wouldn't want to work directly next to a VAX computer for an extended period of time, you know, to sit and word process or whatever. You accessed your VAX system using a remote terminal, a terminal in your office that's connected back to the VAX machine, usually using a serial connection. Now these terminals are all text-based, although you can do some primitive graphics with some of them, but not like a modern display. You're not moving a mouse around, it's very slowly drawing an image on screen at best. Even the fancy storage tube types, you can see it visibly drawing stuff. So Unix is built in this world where the display system, not really part of the computer, it's an external box that you send stuff to and it displays it. And into this world, X was born. So it makes sense from this standpoint to have the X server, the thing that sits there and manages the display, the screen, the keyboard, the input, and the applications talk to it. This fits Unix's established model. The applications run on the normal Unix side of things, and then you have your X display. Now, this can be, in the case of, say, the GS100, a Unibus card that plugs into your VAX, a great big fibre optic out to your terminal. There's a box at the side of the terminal that actually contains a Motorola 68K, like a couple of 100K of RAM, a CRT, keyboard and mouse. So in this model, all the display duties are essentially done by that side box on the terminal. The display is external to the computer, more or less. The Unibus card is just there as a way to communicate at speed with the graphics display terminal. They're not thinking of a computer built the way that modern microcomputers are built. There isn't just, a CPU, some RAM and a frame buffer all in the same box. Where you run your application code and where your display is are two separate things in the minds of the people working on this stuff. However, they're doing all of this in the era where this is changing. Microcomputers with like a half-competent frame buffer, yeah, they're becoming a thing. We're gonna see microcomputers with a half-functional GUI, like the first Apple Mac, for example, or God help us, Windows 1. Sun was also starting to produce Unix workstations that had a frame buffer in them too. And X's model would also work for those systems. You would just run the X server locally, it would handle the frame buffer, keyboard, mouse, and applications would talk to the X server. And it could all happily run on the same computer. Or some of the X applications could actually go and run on an even bigger computer, like your VAX for example. This is why X's model at the time made sense. It could handle your big VAX-type systems with external displays, each running on their own separate terminals, or it could handle your modern microcomputer-type concept, or what the Unix world would start to refer to as the workstation. Now, before we get much further into the history of X, I should probably mention that today's video is sponsored by PCBWay, the sponsor of a surprisingly large quantity of TechConTube on YouTube. But they also have a sideline in manufacturing PCBs. I mean, everyone's got to have a side hustle in this day and age, right? Right? The service is pretty simple and elegant. You design your PCB, you upload that design to their website, and in exchange for money, they send you back the manufactured PCBs. You have to do a few design roll checks, etc. They'll even do a pick and place service where if you choose from a common set of components, they will surface mount those things to the board for you, so you don't have to set fire to your own fingers with a blow dryer. And if 3D printing, CNCing or injection molding is your thing, well, they can also do that for you too. The thing with X though is it starts off as a project in MIT and it starts getting round other universities and the rest of MIT and people start getting interested in it, but it is very much not the only fruit when it comes to Unix displays at this point in time. Sun have started making some progress with their system, SunView. Now SunView works a lot more like most computer displays function these days, in that you have the kernel policing some access in and out of the video cards, and applications make calls to the kernel to get stuff displayed, or eventually they do through a chain of libraries. And Sun's really started to have some success with this thing, as in vendors have started to target using SunView for their applications. Now, in the world of Unix at this point, there's a bit of a war going on between lots of different camps in the Unix world. You got AT&T and Sun trying to do their thing together, and you got lots of other Unix vendors trying to do their BSD thing somewhere else, with each individual Unix vendor doing their own not-so-compatible thing, hoping that that will be the bee's knees and somehow take over the entire Unix market. And for most of them, it's not going particularly well. I mean, Sun's doing alright, but for the rest of them, yeah, this whole lack of compatibility is really helping to not drive the adoption of the Unix workstation. Now, while all this is going on, X has got to version 10, and it's hit the point where it's almost usable. Now, I'm not saying this just for comic effect, or to be mean, it does have some serious problems. You still don't have the idea of window decoration, so you can't, for example, resize a window using your mouse, or change between tasks. You got kind of keyboard shortcuts to do it. And that's because you couldn't put the outside decorations around a window to have things like, the resize control to grab hold of, or a minimize button, for example. So X10's hit the point of nearly there, but not quite. at which point some bright spark in deck comes up with the idea of maybe we could create a new version of it and create an open standard around X and get everyone to embrace this, and somehow he sells X management on this. And in turn, somehow the rest of the Unix industry gets on board, including Sun, who already have a successful product in SunView and have just developed a new system known as News that uses PostScript as part of its display system. But Sun are like, hey, we like an open standard, and suddenly they're on board. So initially they decide they'll all work on this together and start collaboratively coding this together over the internet. Unfortunately, it's 1986 and the internet is pants. So this ends up becoming posting tapes to each other using the US Postal Service. Yeah, that doesn't go that well either. So here's where they make a key change. They decide to start something called the X Consortium, who would hire a number of dedicated developers that MIT would host, so they could all be in one place together and code in one place. Now this is both a good thing and a bad thing, like most things in the universe. I mean, the good side of it is you can now get some actual coding done. You're not spending most of your life trying to post tapes around and figure out what someone else did. Bad side of it is these developers are being paid for by a number of Unix vendors, which means only these Unix vendors get any say over how X is shaping up. And this group doesn't include anyone who, might want to write an application for this thing. Universities have also been a big part of developing all of this stuff. Well, they're cut out the loop too. In fact, anyone who kind of has any idea in which direction computer graphics are going does not seem to be part of this. But out of this X consortium, we get released the first version of X11, and of course a reference implementation that each Unix vendor can take and do their own thing to it, which from the Unix vendor's point of view feels really good. They're getting a thing that they can take and make their own changes to. However, this could also be considered quite an issue because each vendor's going to make their own changes to it. But we'll park that there for a second and we'll look at what X is and what X isn't at this point. There's a little phrase associated with X, which is process not policy. X gives you the mechanism for getting at the screen and getting stuff drawn in Windows. It gives you a way to get your keyboard and mouse events. It even gives you a way of potentially moving some data between applications. What it does not tell you is what the hell any of this should look like. What determines what things should look like in the world of X is up to the application vendor really, and which widget set they choose to use, which brings me on to widgets. Yes, X has widgets it has got. Widgets are the little graphical elements that make up modern GUI applications. Your text box, that's a widget. Button, widget. Scroll bar, widget. I think you're getting the idea. If you see it on the screen and it's reused, it's a widget. But with X, process and not policy, there is no default X Windows widget toolkit. In fact, the X Consortium produces two things you use to interact with X. Xlib, which is a C library that does all the sort of protocol stuff for X for you, for the client, and some utility stuff that I don't think anyone ever used, and a library called XT that can be used to write widget toolkits. No widgets. Now for some, this was great. They already had something called OpenLook, which is a nice look and feel, so they made a widget library that implemented that on top of X. In fact, they made a few. We'll come on to Sun's X implementation in a minute, but they made quite a few APIs available. They had a SunView-like API, so you could take SunView applications and that would port it to run on top of X using an OpenLook toolkit. They then wrote an OpenLook widget toolkit that made use of Xlib, and then they wrote one that made use of XT, because apparently you needed more than one way to do that. And we'll just sidestep the new stuff for a minute or two. And that's just the stuff that Sun got up to with its AT&T collaboration over OpenLook. Another widget set appeared called Motif that a number of the other Unix grouped together to create under an umbrella organization called the Open Software Foundation. No, that does not mean it was under an open license. Again, licensing we're going to have to come back to. But this approach with multiple widget toolkits is a bit of a nightmare for software vendors because they've got to play pick a toolkit. You pick one toolkit, well that means you run on some Unixes. Pick a different toolkit, well that means you run on other Unixes. This does not make life easy for a software vendor. But life was also not easy for the Unix system vendor either, as they kind of made a rod for their own back in the form of the license that all this was done under. X was licensed under the MIT license, which meant that any of the Unix vendors could take the source, do what they like, but they didn't have to give that source back. That source was then closed. which at the time each vendor liked because they thought they could take X, do their thing with it, and make their version better than everyone else's, therefore take over the market and become crowned king of all Unix land. Yeah, it didn't work out that way though, did it? The problem is no one Unix vendor was going to come up with a supreme idea that would allow them to squish all the others. I mean, Sun came closer than anyone else did to taking the market as a whole, but even then, yeah, it didn't, did it? This licensing model also made it very difficult for the X consortium to collaborate with each of the individual Unix developers. So you had situations where, say, X consortium would be working on a frame buffer driver, sort of a generic frame buffer model, and some vendor would also be working on one. The two couldn't collaborate, so you'd end up with two implementations and the effort would be kind of wasted, as it were. But the worst part of this is it locked them into the core X protocol, X11. No one could really change anything, because if one vendor did something and it worked, well, that would be their special thing. They'd have to keep that special thing. But application writers couldn't embrace any of the special things, because if they did, they locked themselves to a really smaller section of the market. So they all had to stick with things that used the core X protocol. Which is why, even to this day, we're still stuck with the same core protocol we had in the 1980s. That's why there's no X12, it's still X11. This gave rise to the extension models to X, where you can extend the protocol with a particular extension, and a vendor could choose to implement that extension or not. And this, it's optional thing, kind of killed some really promising things. So IBM and Adobe developed this thing called Display PostScript, which is not a bad idea, and a number of the various Unix vendors made it available as an extension to X Windows. But hardly anyone could write an application for it, because you couldn't depend on it being there on any one given Unix workstation. Because of course, each vendor would want to charge an extra amount for their special thing, so even if you were targeting only, say, IBM's version of Unix, AIX, then that workstation may or may not have Display PostScript, so you can't really target it. Now, it's not like all of these problems couldn't have been avoided with a better choice of license. And here's the kicker, they had the person who created the better license that they needed in the building, in the form of Richard Stallman, who was at MIT. And apparently quite frequently, he would drop down to the offices of the X consortium and rail against them for not using the GPL. Now, you're going to have to bear in mind for this next bit that Richard Stallman was right. But also, Richard Stallman is an incredibly challenging individual, or at least that's the polite way many of his former colleagues described working with him. Challenging. And they use that word because they're doing a conference or on a system that has community guidelines that stops them using the words they would probably like to use. And that's what quite a few of the X Consortium developers have sold us. It being challenging to work with Richard is what put them off the GPL and trying to use it. Now, eventually this would change, and the most successful implementations of X would use the GPL and be open source in the way that we now all understand it. But at the beginning, no. MIT license, and frankly, Richard put them off the idea of changing that. So how did early adoption of X go? Well, quite a lot of vendors took it on very quickly. Firstly, Sun, who was probably the largest vendor of Unix workstations at the time, they took the X implementation, and they took their new server, their new PostScript display system, and they smushed the two together, and that resulted in something a little bit unique in the X world, in that it also had the window manager in there as well. Now in X, the role of the window manager is to control how big all the windows are and where they are, and do all the decoration around the windows and provide things like the maximize and minimize button and the close window button and the resize handle, those sorts of things. But because in News, the bit that did the role of the window manager was all built into the News server, it had to be bundled into the X server in the world of X, or at least in Sun's implementation. Later on, that's a thing they would have to unpick and just turn the window manager back into a normal application that just runs and connects to the X server. But that happens when Sun eventually drops News. For former Sun OpenView users, life's relatively good. You've got a library that you can recompile your app against, and that turns it into an X application. So Sun's implementation's pretty good, and customers are fairly happy about it. It also gives them the advantage that you can just telnet or rlogin into a bigger Sun machine and run your application there, and magically it will turn up on your screen. Deck manages to get it implemented in their version of Unix, and they get a number of devices out there with it. They even start getting X running on their VMS operating system, which is what the VAX machines use when you buy them directly from Deck. The Unix vendor that probably has the most difficulty getting X kind of in there is SGI, in that they were using IRIX-GL at the time, a graphics language that would let them do a lot of very clever 3D stuff, but wasn't naturally well suited to doing X windows. And they also couldn't break IRIX-GL because, that was the entire reason people were buying SGI machines. But they did eventually come up with an idea where they got the X server running. In fact, they even managed to get some of their 3D hardware acceleration in use to do some of the windowing stuff. And they created an extension to X that let you still run IRIX-GL, and the output could either be in a window or could go full screen. There were even implementations done for the lowly 386. In fact, one of them would eventually become the leading X implementation, or at least for a while. In fact, we'd even see X in the mid-90s pop up in some really unusual places. At some point, Novell decided they needed a UI running on their NetWare server, somewhere around NetWare 5, so they just threw a copy of X Windows in there, coupled it together with a Java VM, and suddenly you can run Java applications with a UI on your NetWare 5 server. Your dedicated file and print machine. Yeah. We'd also see X Windows implementations get created for Windows. One of the first commercially successful versions was Hummingbird's Exceed, which is available for Windows Free, and then later versions from there on out. Even Apple had an X server, in fact they still do to this day. But it's probably worth mentioning that it was not universally adopted by every single Unix version. Steve Jobs' next computers, well, they never did go with X Windows, they stuck with using display PostScript. In fact, in a similar way to Sun's abandoned News system. Now, who knows if they would have stuck with just doing that, as they never lived long enough for us to really find out. They did their first generations of machine, and then Next was effectively over after that, as they didn't have anything to move to from the 68000, and were purchased by Apple to become the core of their new operating system. If they'd stayed as a Unix vendor in that space, they may have been forced to adopt X just in order to be able to keep having applications developed for their platform. I mean, all their display technology could be run on top of X, and in fact was when they started making OpenStep available for other Unix operating systems. Now, having talked about adoption of X amongst various Unix operating systems, we probably should talk about another class of device that arose around this time, and this arose to fill a gap that in the non-GUI world had been filled by dumb terminals and teletypes and the likes, and they were referred to as X terminals. Now, these were a thin client class of device that's basically a computer, usually a affordable processor for the time, like a 68K or some embedded CPU, with a bit of conventional memory, a bit of frame buffer RAM, and a video chip, and a keyboard and mouse input, and an Ethernet card. Now, these things run the X server and basically nothing else, so it's there to manage the display, keyboard, mouse, and allow a bit of networking to happen. Now, weirdly, despite the fact that it's kind of the client, in the way that most people would think of it as like a client connecting to an application server, it's actually all plumbed backwards from that, as the X terminal is running the server that serves out the display, keyboard, and mouse. So when your X terminal starts, it has to get the application server to connect to it and start trying to put out the login window. And once you log in, the desktop environment then again connects to your X terminal. Now, this is a bit of an odd way round. So for some X terminals, you had to configure your application server, where the applications were actually going to run, to get the X sessions process to connect to your X terminal. So the config for that would just have essentially a list of IPs in it, and what subprocess or X application it was going to run once it finally established the connection to that X terminal. Now, quite commonly, that would be the X logon application, which would ask you for your username and password, and if that was successful, it would then go start up the desktop environment. But it could also be something called xchoose. Now, just remember xchoose for a second, because we're going to come back to it at the end of this next section. Now, this whole process we've described probably sounds a bit backwards from most people's experience with using a thin client type device, and that's because it is. What you really want is for the thin client device to go discover a list of servers and either automatically jump to whichever one it's configured to, or give you a list of servers that it can make use of. And that's where the X Display Manager Control Protocol comes in, or XDMCP for short. Just rolls off the tongue, doesn't it? That gave an X terminal a way to discover machines that were willing to offer a login session over X Windows. And this is where this Xchooser app I mentioned earlier comes in. It's essentially a client for that protocol. So if you had an X terminal that didn't support that protocol, well, you could just get it to connect to one host, and the x-shm handler would then run xchoose, discover all the hosts that were running to run a login application over X, and display that list on the terminal so the user could choose. We also got what's known as xquery, which allowed an X server to essentially remotely query a machine and say, hey, do you have something that would like to connect to me? That way an X terminal could initiate the whole process rather than just sitting there and waiting for a client to try and connect to it. Now, this whole X terminal concept was pretty popular with a lot of organisations to begin with, because their Unix box was, well, a big VAX machine somewhere, which didn't really have a way to hook up a local display, and even if it did, people aren't going to want to sit in the same room as that thing. But even with other systems, the X terminal idea was still relatively popular, as you could buy one expensive machine that's got all the CPU and memory and network card and hard disks and everything else, and deploy a number of much cheaper devices so a number of people could make use of that machine. After all, Unix was a multi-user environment. It's only as the workstation concept became more and more popular that one person, one machine, that X running on your local machine became the most common way of making use of it. So we're now at the point where X is launched, it's in use by most Unix distributions, but with a whole variety of widget toolkits and different X extensions and just the Unix wars in general, it's pretty hard to write one application that's going to run everywhere. And while this doesn't seem to be creating too many problems for the big Unix vendors, things are about to change, because the rest of the world is not just sitting still, letting these guys do whatever they want. The Mac has gone from being painfully unusable to actually fairly reasonable, and Windows is in danger of going from being just terrible to good enough. So this is where we suddenly see the Unix market start to pull its finger out and cooperate a bit more and start agreeing some compatibility standards between each other. And X and the graphical environment is not left out of this whole thing. Eventually they agree that they're going to move to a common widget set. They're all going to start using Motif, and what's more is they're going to create a common desktop environment around this, called the Common Desktop Environment. See what we did there? Now, Common Desktop Environment, or CDE for short, was a standard that all the major commercial vendors of Unix decided to essentially all use pretty much. Again, there are some players not in there doing their own thing. Next, we're looking at you. But you may have noticed how I keep using the word commercial, because we're starting to see open source Unix-like operating systems appear, but they don't have access to CDE or in fact Motif because the license is not done in a way that works for them. In fact, the only widget set they have access to begin with is Athena, the one created by the X Consortium as essentially an example widget set. It's not really intended for use by any serious or large applications, it's there to provide an example of how one might create a widget set. However, if you've been around Unix for a while, or Unix-like operating systems, you will have seen it, largely in the guise of the tiny window manager. Got a nice example here for you to look at. It'll be familiar to some of you. Now, the Common Desktop Environment wasn't the only thing they needed to standardize. There were lots of other standardization efforts going on to make moving an application from one Unix variant to another. I'll give an example of some of the stuff happening in the PC Unix world, in that we got a standard known as COSI, the Common Operating System Interface, which allowed an application vendor to essentially produce one binary application that could be run on all the PC Unix variants out there. So you could run it on SCO, you could run it on Unixware, even Solaris for x86. And we did actually see application vendors producing stuff targeting COSI and CDE, including, from of all people, Microsoft. Yes, we got MS Word for Unix. We even got it to Internet Explorer 4, complete with NetMeeting and Outlook Express. But while the Unix workstation market seems to be finally getting itself together, Windows has become good enough, and Microsoft have finally produced Windows NT, an actual half-serious workstation operating system. And while it's playing catch-up on some features, it's very much got the desktop side of things nailed down in a way that's pretty easy to port from their regular Windows products. So they have access to a lot more desktop developers at this point, and also a lot more applications. And also, thanks to economies of scale, Intel CPUs are starting to become, performance-wise, reasonably competitive with some of the RISC stuff. I mean, the Pentium really is a pretty big leap for the world of x86. So some of the non-Unix workstation stuff really is starting to become good enough. And the problem with good enough is, well, it's good enough. And if it's good enough and a lot cheaper, that's going to start shifting in a lot more volume. So it's over this period from the early 90s to mid to late 90s, we start seeing a fairly big shift in the world of the Unix vendors. Being a workstation vendor, unless you're in a particularly specialist field like high-end 3D graphics like SGI was, is starting to become commercially difficult. Cost-wise, you can't really compete with the whole Intel Microsoft thing because you just don't have those economies of scale to play with. So you have to find niches where you can justify the extra cost that your system goes for compared to, say, a basic NT workstation or just Windows 95, Windows 98. So we end up with these high-end Unix workstations start specializing into engineering with lots of simulation and finite element modeling type stuff, scientific uses where you have huge volumes of data you're needing to deal with, and really high-end 3D graphics. And the problem with being forced to target the high-end is eventually the low-end starts to improve, and things that were only possible on your high-end systems now start to become practical on lower-end, cheaper systems. And this is where we see the remaining commercial Unix vendors start to move away from doing the workstation thing at all. For Sun, luckily the .com boom appears round about this time and they start shifting into server hardware, which essentially brings them to the point at peak commercial profitability for them. SGI goes more and more into the 3D graphics space and then into the supercomputer space. DEC sadly disappears at this point. The PC Unix side of things starts to try to do the sort of SME to mid-sized business application server environment, although they come a cropper thanks to the world of open source. We're going to come to that in a moment. The reason I'm bringing all of this up is it's to mark a point where we go from the lead of X being the commercial Unix entities to the world of open source starting to take over the leadership of X. For the commercial Unixes, the desktop isn't really a prime commercial motivator anymore. They're just not making enough money out of it. For the open source world, that's not really a concern. What they want is a desktop environment that's usable to them. And in many ways, the likes of Windows and Mac OS doesn't really scratch that itch for them. They want a Unix workstation environment that they can afford. And this is when we start to see the emergences of widgets and toolkit sets that are going to be very important later on. We'll also see them start to take control over X and the display server itself. Now, the first set of things that started getting developed in the open source world, widget-wise, is things to replace the commercial widget sets that they don't have licensing access to. So, for example, we end up with LessTeeth, the open source version of Motif, which aims to be both API and ABI compatible with Motif. It more or less gets there with the API compatibility. It never really entirely gets there with the API compatibility, but that doesn't matter because eventually Motif actually gets released with an open source applicable license, so people can swap over and use that. We also see the likes of GNU Step and Window Maker that lets you take applications that you are building for NextStep and build them for open source platforms. But more importantly than this, we start to see toolkits emerging that are open source from the ground up and not a re-implementation of an already existing commercial offering. This is also coupled with things like Linux coming into existence and FreeBSD and NetBSD. So you can start to run a full operating system that has no commercial elements to it. It's all open source. Your compiler and utility chain from the likes of GNU means that you don't have to use, say, Sun's compiler or Intel's compiler. It becomes its own ecosystem and it starts to develop fast. And these new toolkits, the likes of GTK, which was originally created for the GIMP, an image manipulation program that, well, quite a few of you have probably used by now. You also see Trolltech creating Qt, a widget set that's available on the open source Unix operating systems, as well as Windows and Mac, that lets you write an application that can run on all of these operating systems. These two toolkits respectively will become the basis of Gnome and KDE, the common desktop environment. Open source really does like a pun, doesn't it? From the X server point of view, we start to see the commercial X environments don't really have that much say anymore, and X386, the open source implementation, really starts to take the lead. And pretty much all new standards development starts taking place in that X server. In fact, the X consortium, the one based at MIT that did the initial set of releases of X11, they shut down, and some of the lead developers there, well, they start to becoming involved in X386. For example, Keith Packard. Now, I probably should have mentioned him before this point because he was pretty significant in the whole getting X11 going thing, being one of the main developers for the X consortium, but he's going to get really important in a little bit when we start discussing what happened at X386. Now, with the commercial developers not really having much interest in pushing X much further as they're getting away from being involved as a desktop workstation, the core focus of the X386 project is being that desktop workstation, largely running under Linux, but also FreeBSD, NetBSD, and we start to see them introduce some new extensions. And we should probably start talking about the extensions to the X protocol, because although the core protocol was required to stay more or less the same, and the old MIT licensing model really helped nail that one in place, there had been innovation in X, some led by commercial entities, and X386 carrying a lot of the water after that. So let's go over a couple of the big extensions. Now, the first one I'll talk about was actually started by the X Consortium, which is the MIT Shared Memory Extension, or x-shm, and this meant that an X client could use a shared memory segment with the X server and put X images into that and use that as the mechanism to get them into the server and displayed. Now, this only works if both the X server and the client are running on the same machine because they have to share physical RAM, but this means that X can work in the same way as more modern UI technologies like Windows and Mac, with of course the rendering speed advantages and the reduced latency. And if your X application and server aren't on the same machine, then you can't use the shared memory extension, you just fall back to doing everything with the core protocol. Now, we got this in 1991, so commercial Unix is very much in the lead at this point still. The next extension I'll mention is X-Video. This is again from around 1991, and this is an extension to allow smooth video playback via X, which is not exactly a thing other platforms were worrying about at this point with UIs. I mean, no one's trying to play back video on Windows 2. But with these high-end Unix boxes having the kind of CPU that can decompress some video, the X-Video extension allows the scaling and the changing of color space to all be offloaded to the graphics card where it can be best handled. A later extension would even allow the hardware to do motion compensation. Other significant extensions were the security extension that stopped X being quite the security nightmare it once was, as one of the issues of a display system that allows you to fire an application up on almost any host over the internet is that someone in your lab will go and do that, and you'll have something on your screen that maybe you don't appreciate being on your screen. I'm not saying we did that in our comp sci lab, but yeah. So, some tightening up of security was very much needed. Although if you're prepared to mess around with the config file of a modern X server, yeah, you can turn it back into the insecure basket case it started off as. We had the X keyboard extension that let you, well, take keyboard input in a half-sensible way. It handled grouping of keys together properly. You had control over the lights on a keyboard, for example. Modifier keys were handled in a half-sensible way. I mean, these are all things that probably could and should have been done in the X-Core protocol, but remember, we can't really touch that, so we're going to have to go with an extension that almost everyone has to implement. But let's talk about the biggie. The one that would come to dominate the world of display graphics for the personal computer, 3D. Now, initially with X, this does not start the way you're probably expecting. I know a few of you thinking, oh, cool, he's going to talk about OpenGL, but not yet, because we're going to talk about FIGS. Now, FIGS becomes a standard in 1988, and is based on a lot of the ideas from the graphics kernel system, which itself was an earlier standard that was started in the 70s, had gone through a few iterations and changes, and by 1985 it was a ISO standard. And it was there mostly for doing vector graphics. In fact, it's what GSX, the graphics extension to CP/M, was based on, and in turn VDI that was used in GEM Desktop. So you can think of FIGS as like the 3D extension to this thing. And it was a system that was very much designed by committee, and X Windows had support for it in the form of the PEX extension, FIGS Extension X. Now again, all the commercial vendors pretty much got on board with this. We had SunFigs, which was Sun's version of it. DEC were equally imaginative and called their version DECFigs. IBM had a little bit more imagination and called theirs Graphigs. The problem was, FIGS was a little bit difficult to hardware accelerate, and almost impossible for the software developer to get into how it's rendered and what it looks like come the end. Figs use something called a scene graph, which is essentially a central database where you put in all the things you want to be rendered in the scene. So the whole model has to be built up in what they call a centralized structure store, or CSS for short. And Figs essentially renders you out what's in that store. As a developer, you're just putting things into the store. But as renderers go, most of the Figs renderers were kind of missing really useful features like, say for example, texture mapping. You couldn't do things like illuminated scenes, for example. All the developer did was modify the things that are in the store, and any changes to that model would be immediately rendered out by Figs. Now, this model might have hung around for a while if it had not been for SGI. Even before Figs, SGI had started to become a bit of a player in the world of 3D graphics. They had a system known as IrisGL, GL standing for Graphics Library, and that did things very differently. It's what's known as an immediate mode renderer, i.e. you don't pass it and build up a whole model. It has no internalized state. You send it the thing to render, it renders it, it's done, it disappears out of memory. You want the same thing again in the next frame, you send it into the pipeline again. Now this had some pretty good advantages. First of all, you didn't have to send anywhere near as much to the graphics card. You're not shifting an entire model. You can use the CPU just to pull out the bits that you need rendered at that point and then send those across the bus. It's also easier to build the hardware acceleration into the hardware too. The CPU can do the bits that it's good at, and the graphics pipeline can do the bits that are easy, well, to do in a graphics pipeline. Although it did have the disadvantage for smaller systems, it was harder on the developer compared to Figs, as essentially you have to write the 3D engine-y bits that work out which bits to send out to the graphics card to render, and what to ask the graphics card to do. In Figs, you just had the code that built the model, then you shoved the model at Figs. Now, when SGI eventually got to the point where they could adopt X, they put an extension in their X server that let you talk to IrisGL, or should I say, its successor library. IrisGL was getting a bit long in the tooth, and the library could do with a bit of tidying up for maintenance reasons. So SGI decided that it would clean this library up and also open it up somewhat more so others could start making use of it. As SGI figured it was better to be the leading supplier of an open system than it was to be the only supplier of a proprietary system. And thus, we get OpenGL and the extension X to allow you to use it, GLX. Now, you probably know how it went with these two competing standards because you'll have all heard of OpenGL and it's in use in almost everything still, even though it's not actively being developed anymore. I mean, it's hard to think of a modern platform that doesn't have OpenGL support. I mean, pretty much everything out there does. In fact, even for 3D on the PC, it was instrumental in those early DOS years when we had the likes of 3DFX, as their library Glide that made all of this possible was based on OpenGL. And from OpenGL's release in 1992, control of the standard was handled by OpenGL's Architecture Review Board, which included lots of different organisations and companies. And in 2006, control of that standard was handed off to the Kronos Group. Now, unsurprisingly, the success of OpenGL and the GLX extension meant that no one was really using PEX or Figs anymore. So, that extension from X was dropped. Yes, extensions can be dropped. And in fact, Figs is not the only example of that. But it is the only example of an X extension I can think of where it got dropped and would mean that some applications that previously worked over X11 won't work anymore. The other examples of dropped extensions don't really prevent things from working, they just make them fall back to the X core protocol again. So an example would be Low Bandwidth X, an extension to the X server that let you run a remote X proxy on a machine you logged into. The X application should be configured to talk to that X proxy on that machine, and the X proxy would compress all of that and send it through to the X server you were using. And that was fairly handy if you're doing things like connecting up to your machines via a modem. But that extension was dropped because what we think of as low bandwidth these days is not really low bandwidth as it was back then. And also, in terms of performance, latency was a much bigger problem than the bandwidth was. But when that extension got dropped, there were no applications that stopped working. Your applications just didn't go for the proxy anymore and everything was fine. In fact, I can run X applications from the 1980s now and they will still work with my modern X server in 2024. Without doing a load of emulation, I can't think of another modern UI system where that's true. I mean, Windows 11 is not going to run a Windows 1 app. But Xclock, written in 1984 and targeting X10, Yeah, still works just fine on 2024 on my modern PC. The introduction of 3D and the GLX extension into X11 created quite a lot of work for X server developers, particularly the X386 project. Things were not too bad for the commercial Unix vendors. In their X server, they only had to support their graphics cards. And for some of them, like SGI, 3D graphics were their entire thing, so controlling more or less the whole stack like that made life a lot easier for them. For the likes of the X386 server and Linux, things were somewhat more complicated. For a start, there's not one 3D card vendor you're going to have to deal with, there's loads, and also, you're not the 3D card vendor. So, you're going to have to create interfaces between X and the kernel, work out which bits are going to run in kernel, which bits are going to work out outside the kernel. You're going to have to come up with a hardware and driver acceleration model for your X server for 3D. Because previously, you'd had a bit of 2D acceleration to deal with, and the X Consortium had kind of given you a driver model for display drivers anyway. Yes, the commercial Unix vendors had all done their own GLX implementations, but for the X386 people, whatever they'd done was all closed source, so they had no idea what the commercial vendors were doing. And also, because it had to support like 1 or 2 proprietary cards made by those companies, it probably wasn't very applicable to what they needed to achieve anyway. So now the X386 project had to become the driver of innovation from this. They went from following a standard and trying to implement it as best they could to being the people who are now developing and creating these standards. And what came out of this was fairly complicated, so buckle up. One of the big things the open source community created was DRI, Direct Rendering Infrastructure. This allowed a local X client, one that's running on the same machine as the X server, to get access more or less directly to the hardware using the 3D library, like the OpenGL implementation. Now, initially, all these implementations were pretty much provided by the Mesa 3D library, but these days, commercial vendors such as Nvidia and ATI, well, AMD now, will provide a library to do this as well. Although the likes of AMD have got a lot more on board with the idea of open source and these days contribute code and the information necessary to the Mesa 3D project. Nvidia, are you listening? Be more like AMD. These libraries get to talk directly to the kernel using something known as DRM, the Direct Rendering Manager. And this is why the proprietary drivers for modern X have a few components. They have the 2D driver for X Windows, they have the 3D library, and a kernel module. And of course, for each of the versions of DRI, X has had to produce a protocol extension to manage the whole thing. GLX is still around, so you still have indirect rendering support, so a X application on a remote machine can have hardware-accelerated 3D rendering, but thanks to the latency, it does kind of suck. Now, while all this stuff is starting to get going with 3D and X is changing to accommodate that, mostly in the open source world, commercial usage of X-based workstation desktops has kind of fallen off a cliff. But the open source people, well, they've been building stuff left, right and centre. And 2 big desktop standards have emerged. That of Gnome, largely sponsored by the Free Software Foundation, and based on the GTK widget set, and KDE, the common desktop environment, based on Qt. That's not to say that there aren't others, there are other projects and efforts going on and still continue to this day, but they don't have the user base of Gnome and KDE. And honestly, if we're doing a video just on desktop environments for X Windows, it could have a 2-hour runtime and still not touch the sides. In fact, Sun's last commercial workstation offering was actually based on Gnome, so that shows you how far it had come at that point and how much it had overtaken the likes of CDE. But all was not happy in the open source garden. Developers of X386 were starting to get quite frustrated with the way the project was being run and how difficult it was to get changes added into the project, to the point where most Linux distributions were maintaining a very large patch set outside of X386, as only members of their core architecture team had any commit access to CVS. But things seemed to come to a head initially around Keith Packard and the Xfixes extension. The Xfixes extension was one of the most useful things to have happened to X Windows for quite a while. It fixed up and replaced some of the bits that were basically just missing from the core X protocol, and as it was implemented as an X extension and done in the device-independent part of X Windows, it should not really have been such a big deal to everyone as it turned out to become. Keith committed it to X386 during the merge window for an upcoming release. as it had been something he'd been working on by himself up until that point. Other core members of the X386 team seemed to get a bit upset about this, so they removed his commit access to the project. Now, in the eyes of the people outside of the X386 project, this seemed to be another example of the kind of symptom that was showing how the project was not really being run in a community way. Keith had also done a ton of work on X over the years, starting with the X Consortium and working all the way through with X386, and was one of the more approachable members of the core team for people who were not members of said team. This, along with the reverting out of the X fixes changes, kinda left a bad taste in the mouth for the rest of the world. Then the core team decided to expel Keith from the core team. So after that, Keith started xwin.org and started to put together a fork of the X386 server. That effort got moved to freedesktop.org, and then eventually that became the Xorg X server. Now, the big push for this was the change of license. For some reason, X386 decided it would try and change its license, and most distributions were telling them that license wasn't compatible for them. But the core team at X386 didn't seem to be listening or willing to listen. And with the Xorg X server coming into existence and a lot of the developers jumping ship to work on that instead because, well, it was less of a pain in the arse to work with that one, almost every distro switched. And with almost all the developers having moved across to the new project, and almost every distro using it, 4 short years later we would see the final release of X386 in the guise of version 4.80. But this did now mean that we saw all the development effort concentrated in Xorg, with much more of an emphasis on improving the X server, so desktop environments could really start doing the sort of things they wanted to. And this rising tide really did seem to raise the boats of all the major desktop projects, as we saw improvement after improvement, all focused on giving the users the experience that they really wanted. Now, one of the core things that the Xorg server had to do was get rid of a lot of the old cruft. Given they could trace their lineage back to the 1980s, with all the extensions and other things that had built up in there was a huge codebase that was very difficult to maintain, and quite a lot of it was not really in use. For example, there were things like the Xprint server, which was essentially another complete implementation of X, where you would talk to it like it's an X server, build up a document, and then dispatch that to the printer. For some reason, that had been created and was still a thing, despite the fact that, PostScript exists. The low bandwidth X extension was finally removed. We finally got a font handling system that was modern and could do, anti-aliasing. But the priority had also changed to support modern uses of X Windows. By now, almost every application that's talking to your X server is running on the same machine as the X server. Now in the past, that was a lot less the case, as we had lots of remote X terminals that didn't run any applications locally. The X terminal would run the X server, and everything else would run on a remote Unix box. But the remote X server is not really a use case for, anyone these days, and there are better ways of handling that stuff now. Protocols like RDP or VNC. And although the Xorg server was being changed so that it optimized for the you can use shared memory and direct access case, that meant that what X was becoming was an extremely complicated method for doing IPC. And in the community we had a growing realization that effectively X was the problem. The X11 protocol and design was the thing that was getting in the way of improving and making desktop experiences better for users. And the fact that most graphics hardware had swapped over to being primarily focused on 3D meant that the 2D acceleration driver and hardware model for X, again, not really that suitable for the modern world. And even though Xorg has attempted to replace its 2D driver model, with the idea being that the 2D stuff is just stuff on a texture in the 3D hardware, it was realised that X at some point was gonna have to go, or at least not be the primary way in which we handle our displays in Unix-type systems. A new project called Wayland eventually gathered enough developers and critical mass to become the generally accepted future of how we're going to do rendering in the desktop environment for Linux. Now, admittedly, it's been the future of the Linux desktop for about the last 10 years now, it feels like. But now we're not just getting distributions that are previewing what it might be like and giving you a version that dies fairly regularly or only works with 2 graphics cards. Now we're actually getting distributions swapping over to it by default. In fact, the only real problem is NVIDIA, who seemed to at one point have been dead set against doing anything half useful for the Wayland community, but a way seems to have been found forwards to deal with all of that. AMD have been pretty useful and friendly from this on quite a long time now. For the likes of the Gnome desktop and others, getting initial Wayland support working was not terrible. Both Qt and GTK already had the idea of supporting multiple rendering backends in there. For example, GTK could render to direct frame buffer, or Windows. So there was a good place they could insert their code for Wayland support without affecting any of the X11 rendering. Now, the model for Wayland is a lot simpler and is again predicated on the application running on the same machine as where all your graphics hardware is. There isn't directly support in Wayland for running something on another machine. If you want something like that, you have to use either RDP or VNC, something like that. I'll give you a quick high-level view as to how Wayland works. I am going to skirt over quite a lot of the details here, by the way. Everything in Wayland relies on 3D graphics hardware. When your application starts, it is effectively given a texture, that is its window. The application renders into that texture, and then the Wayland compositor that comes with your desktop environment essentially stacks those textures together to make the windowing environment. It resizes textures, it layers one on top of the other, that sort of thing. And it means all the stuff to do with windows, clever transparencies, moving them around, shrinking them, resizing them, etc. is all hardware accelerated. There's no IPC or protocol to get in the way of your application just shoving what it wants into that texture memory. So it's all very low latency, which is what you want in your desktop environment. You don't want Windows stuttering and tearing. I mean, I've missed a lot of details out there, but that's basically the way Wayland works, and it's a lot simpler and fits in with the way modern hardware is designed. So that's it, right? After 40 years, X11 is finally dead. Well, no, not really. Even though most of our modern machines may be swapping over to using Wayland if you're a Linux user, very shortly, even if you've not already, 40 years of software is not just going to go away or suddenly get modernized to run on this stuff. And this is where Xorg's X server is going to do us one last good turn. You see, the Xorg server can render its output to Wayland. Yep, effectively it has a Wayland graphics driver. So when you start an X application in your desktop environment that doesn't have Wayland support, your desktop environment dynamically starts up Xorg and lets the X application speak to that. The Xorg server in turn renders that out into a Wayland window. So what we have is a system that's perfectly X compatible, yet gives us a new way forward to not have to use X and have a very low latency between application and rendering environment. Also, Wayland is based on all the same 3D libraries that we've been using for X since, well, the 1990s. So, huge quantities of the code is reused by Wayland. If you've made it to the end of this 40 years nearly of X history, I'd like to say thank you very much for watching, and hopefully the fact that I'm starting with a cold has not been too distracting. If you enjoyed the video, why not click that little button that YouTube has put there just for the purpose of indicating that fact. There is also another button, and if you feel like pressing that, well, thank you for the engagement. I'm particularly looking forward to reading all your comments related to X and Unix history, as honestly, you guys put some really fascinating things into the comments, and if you're not one who feels like commenting, do check out the section below, because you're going to get a load of extra detail from people about different systems and things they've done with X in the past. If you would like to help the channel out, please do click the subscribe button, because it seems to make the YouTube algorithm tell people that these videos actually exist.